Hello, Accelerated Math 6-7 students. We are working in Module 6, and this is lesson. Let me grab a pencil so I can write it in with you. The name of our lesson today is called the mean absolute deviation. The mean absolute deviation. Let's write that. The mean absolute deviation. Oh, let me make sure I spell deviation right. Deviation. Okay. All right, and you're going to put it on your page that you have. All right, the mean absolute deviation. This is lesson 5. Okay, so let's get our notes. Mean absolute deviation. This is actually a very fun lesson. It can kind of be tricky, but it's very fun. Okay, the mean absolute deviation, and we call it MAD for short, so we don't have to say all of those words. All right, and because sometimes when people get done doing the mean absolute deviation, they feel like they're going to go mad, but don't worry, we'll get you through it. All right, so our goal for today. Today we will use the mean absolute deviation to describe the spread of a data set. The question that I want you to be thinking about during this lesson is, how can we represent the spread of a data set with a single number? Okay, things to know. We already know mean. The mean, you've been working with it for several lessons now. The mean gives you the average of the data set, so the fair share. So what would every person in your group get? What is their fair share? What is the average of the data? Okay. Absolute value, you already know. The absolute value is the amount of distance from each data point to the mean. So your comparison in this lesson is the mean. So you're going to find the mean first, and then you're going to find the absolute value of each data point. So you're going to compare the data point to the mean and find out what is the distance. We've been working with that in previous lessons. Remember, with the balance is the mean. Okay. Deviation tells you how far the average of the absolute values are from the mean. And that's when you take all of them. All right. So mathematicians use tables to organize mean absolute deviation. Let's look at this table because this table is really going to help us understand all of this. So let's say we did a survey, and the survey was about pets. And we asked every sixth grader in our school, what is the number of pets that they have? All right, and so we're looking at it from this point of view. One person said they had 3 pets, another person said 2, another person said 3, another person said 5, another person said 5, and the last person surveyed said 6. Okay, so this table is really helpful for finding and locating all of your information. So you're given the data points from your survey. Your next job is to figure out the mean. The mean is not going to be given to you. You have to figure it out. So if you remember that process, in order to find the mean, what we do is we add all of these points up. So we have 3 plus 2 plus 3 plus 5 plus 5 plus 6. Okay, so we're adding these together, and we know that 3 plus 2 is 5. And we know 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this should be 24. So if we have 11 plus 10 is 21, 22, 23, 24. Perfect. Okay, so we have 24, and there are 1, 2, 3, 4, 5, 6 data points. So you're going to take 24 divided by 6, and we get 4. So our mean is 4. Okay, good. So we showed work on how to find the mean, and we figured out the mean was 4. All right, good. The next thing you have to do is you're going to take the deviation from the mean. So remember, we're taking the data point, and we're finding the distance from the mean. So if you're looking at it on a number line, because some of you like the number lines as visuals, so I'll draw the number line down here. And we have our mean is 4. So here's 0, 1, 2, 3, 4, and then your data point. So remember, this is our balance point right here. Our mean is 4, so we're trying to figure out what is the distance from here to here. And we know that as -1 because it's left of the mean. Okay, so then we're trying to find where it would be at 2, so we're going over here, and we get -2 because it's to the left of the mean. And then we go back to 3 as our next data point, so we have -1. and then we have 5, so we have 5, and then we have 6. Let's put those on our number lines. Okay, so we have 5, so we go down here to 5, and we say this is positive 1. And then we have another 5, so we say this is positive 1, and then we have a 6, so we know this is positive 2. Okay, so now we figured out the deviation. So if you look up here, we have 3 away from 4 gives us a negative 1, 2 away from 4 gives us a negative 2, 3 away from 4 gives me a negative 1, 5 away from 4 is 1, 5 away from 4 is 1, and 6 away from 4 is 2. So now we have, if you look up here, the deviation from the mean. That's what this column gave us. Okay. So now we take the absolute values of those deviations. So remember, this is the deviation, so we're taking the absolute value. What is the absolute value of negative 1? 1. The absolute value of negative 2? 2. The absolute value of negative 1? 1. The absolute value of 1 is 1. The absolute value of 1 is 1. The absolute value of 2 is 2. So we get that. Okay, so now your job, it's kind of funny, but you're going to take the mean of these. Okay, so the mean of the absolute deviations. So remember, in order to find the means, what do? We take all of the numbers and add them up. So we have 1 plus 2 plus 1 plus 1 plus 1 plus 2, because that's what's listed right here. Add those together, so we get 2, 3, 4, 5, 6, 7, 8. We have 8, and we're dividing 8 by 6, because that's how many data points there are. 6 goes into 8 one time, with 2 leftovers, so 2, 6. And 2, 6 simplifies to 1/3. So the mean absolute deviation is 1 1/3, because 1 and 2, 6 simplifies to 1 1/3. So the answer to this one is the MAD, mean absolute deviation. The MAD for this data set is 1 1/3. Done. That's all you had to do. Do you see how this table is very, very helpful with organizing your information? Okay. So let's go over it again really quickly. You find the mean. Here's an example of finding that mean up there. Okay. So we have that information. Then you have to find how far away from the mean each one of these points was. So we did that with our finding our balance. Then you take those distances and you add them all up and divide by 6, and you get 1 1/3. So find the mean first, find the distance from the mean, then find the mean of the distances, and that gives you the mean absolute deviation. Okay? Not too hard, as long as you have a table to remember all the steps. Okay, so you get to practice one now. Woohoo! All by yourself. All right, so practice this one. Suppose that 7 students polled the following numbers of jokes on April Fool's Day. So April Fool's Day is coming up, and one student, student number 1, told 1 joke. Student number 2 told 1 joke. Student number 3 told 1 joke. Student number 4 told 2 jokes. Student number 5 told 4 jokes. Student number 6 told 4 jokes, and student number 7 told 8 jokes. Okay, your job is to determine the mean and the MAD below. So don't look at the student numbers. Don't let that confuse you. Look at the jokes. So again, you're going to find the mean. So remember, we add all of the data points up. So these are your data points. So you're going to add all of those up and divide by 7, because there are 7 kids. Write your mean in here. Show your work right here, like we did on the other page. Then draw your balance point, okay, whatever your mean is, and then draw your balance points to find the deviations or the distance from the mean and put them in here. Then you have to take the absolute value of those, and then once you have the absolute value of those, you're going to add all the absolute values up, divide by 7, and that will be your MAD, your mean absolute deviation. Okay? Pretty simple. As long as you watched the video and paid attention to what we did over here, this practice problem is going to be easy cheesy, and I will be looking for this answer when we get in class tomorrow. Okay? All right, goal for today. Today we will use the mean absolute deviation to describe the spread of the data set. Oh, how do we describe it? We say each data point is 1 1/3 away from the mean. That's how we describe it in words. Each data point is 1 1/3 deviations away from the mean. Okay? How can we represent a spread of data of a data set with a single number? Ta-da! By finding the mean absolute deviation. That's how you can do that. how can we represent a spread of a data set with one single number by using the mean absolute deviation or by using the MAD. Okay? All right, kiddos, that's all I have. Good luck on your problem. It should be fun. Follow the chart and it will help you. All right, I'll see you all in class later. Bye.